9.1. A rolling bridge has a steel rod which can be rolled along its length. The length L and the radius R of the rod are 2.25 meters and 5 millimeters respectively. A force of 125 kilonewtons stretches it along its length. Find out stress, elongation, and strain on the rod. Given Young's modulus of steel is 2 into 10 raised to 11 newtons per square meter. Solution. Considering the structure of the bridge, we assume that the force experienced by the rod is parallel to its length and applied to one of the ends, whereas the other end is fixed in space. Thus, the stress on the rod equals F by A equals F by pi r square equals 125 into 10 raised to 3 by pi into 5 into 10 raised to minus 3 whole square equals 5 by pi into 10 raised to 9 newtons per square meter. The net change in elongation, that is delta L, equals F by A into L by Y, or delta L equals 5 by pi into 10 raised to 9 into 2.25 by 2 into 10 raised to 11 equals 1.791 into 10 raised to minus 2 meters equals 1.79 centimeters. Thus, strain equals delta L by L equals 1.79 into 10 raised to minus 2 meters by 2.25, approximately equal to 0.8%. Example 9.2. Two dissimilar wires made up of wrought iron and aluminium are joined end to end. They have the same radius R of 6 millimeters, but their lengths are L, Wi, and 2.4 meters, and LA equals 1.8 meters respectively. Obtain the load applied on this combination if the net elongation found after the application of this load was 0.66 millimeters. Given YA equals 70 into 10 raised to 9 newtons per meter square. YWI equals 190 into 10 raised to 9 newtons per meter square. Solution. From the given problem, we can conclude that both the wires experience the same force in the form of a tensile stress, as because they have the same cross-sectional area and the same load, let the load be ML. Stress equals F by A equals ML by pi r square. Also, stress equals delta L by L into Y. Hence, ML by pi r square equals delta LA by LA into YA equals delta LWI by LWI into YWI, or delta LA by 1.8 into 70 into 10 raised to 9 equals delta LWI by 2.4 into 190 into 10 raised to 9, or delta LA by delta LWI equals 1.8 by 2.4 into 190 by 70 equals 3 by 4 into 19 by 7 equals 2.035. Also, given that delta LA plus delta LWI equals 0.66 millimeters, as delta LA equals 2.035 into delta LWI, delta LWI into 1 plus 2.035 equals 0.66 millimeters, or delta LWI equals 0.66 by 3.035 millimeters equals 0.2174 millimeters. Hence, delta LA equals 2.035 into 0.2174 millimeters equals 0.4424 millimeters. Now, to calculate the velocity of ML, we have ML by pi into 6 into 10 raised to minus 3 whole square equals 0.4424 into 10 raised to minus 3 into 70 into 10 raised to 9 by 1.8, or ML equals 0.4424 into 10 raised to minus 3 into 70 into 36 into 22 by 1.8 into 7 equals 194.656 newtons.
Example 9.3. The given figure shows a traditional dance in Indonesia. The entire weight of the performer A, who is on top, is supported by another performer B, who is lying on her back. The net weight of the entire arrangement, along with all the objects used for the performance, is 125 kgs, and the mass of performer B is 55 kgs. The length of the thigh bone of performer B is L, 45 centimeters in length, and has a radius R of 2.25 centimeters. Calculate the compression in her thigh bone, assuming the load is uniform all throughout. Given Y bone equals 9.4 into 10 raised to 9 Newton per meter square. Solution. The net mass of the entire arrangement equals 125 kgs. The mass of performer B equals 55 kgs. Hence, the total mass supported by performer B on her single thigh bone is 125 minus 55, which equals 70 kgs. Hence, weight of the supported mass equals 70 into 9.8 newtons, which equals 686 newtons. This will be the total load, M load, for the purpose of calculation. Now, the cross-sectional area of the thigh bone is A equals pi r square equals pi into 2.25 into 10 raised to minus 2 whole square meter square. Now, we know that delta L by L equals F by A by Y. Or in this case, as F equals M load, Y equals Y bone, delta L equals L into M load by A into Y bone, which equals 45 into 10 raised to minus 2 into 686 by pi into 2.25 into 10 raised to minus 2 whole square into 9.4 into 10 raised to 9 equals 2.06 into 10 raised to minus 5 meters. Also, the fractional decrease in the length equals delta L by L, which equals 2.06 into 10 raised to minus 5 by 45 into 10 raised to minus 2 equals 4.57 into 10 raised to minus 5 equals 0.00457%.
Example 9.4. A square steel suitcase is riveted to the floor for testing the endurance of the product. The side S is of 36 centimeters and the thickness T is 12 centimeters. On the application of a shearing force Fs of magnitude 6.6 into 10 raised to 4 newtons on the narrow face, the upper edge was displaced by delta y meters. Calculate delta y. Given Gs equals 84 into 10 raised to 9 newtons per meter square. Solution. The force is parallel to the face PQRS. Area of PQRS of A equals S into T equals 36 into 12 centimeters square equals 432 centimeters square equals 0.0432 meters square. Hence, stress equals Fs by A equals 6.6 into 10 raised to 4 by 0.0432 newtons per square meter equals 1.52 into 10 raised to 6 newtons per square meter. We also know that shearing strain equals stress by Gs equals delta y by S. Therefore, the net displacement parallel to the PQRS plane equals delta y is delta y equals S into stress by Gs 0.36 into 1.52 into 10 raised to 6 by 84 into 10 raised to 9 meters equals 0.0065 into 10 raised to minus 3 meters. Example 9.5. The Pacific Ocean has an average depth of 4.2 kilometers. It is also given that the fractional compression delta V by V, as calculated by the National Geographic team at the bottom of the ocean, is X%. Find out the value of X. Given that bulk modulus of water BW equals 2.2 into 10 raised to 9 newtons per meter square, density of water ρ equals 1000 kilograms per meter cube. Solution. Firstly, we calculate the pressure experienced in the ocean bed, which is at a depth of 4.2 kilometers, equals 4,200 meters. P water equals H rho G equals 4,200 into 1,000 into 9.8 equals 4.11 into 10 raised to 7 newtons per meter square. Hence, P water will be the stress experienced at the ocean bed. Now we know that delta V by V equals stress by BW equals 4.11 into 10 raised to 7 by 2.2 into 10 raised to 9 equals 1.868 into 10 raised to minus 2 equals 1.868%. Hence, the value of X equals 1.8